Okay, that is a good start. It's actually going live. Oh, that's actually already loaded and in the chat. Okay. Let's actually just give this a little bit for people to join if they want to join. I will also make this text a little bigger because not everybody is like me and likes really tiny text all the time. So, while we're waiting, let's have a quick background of actually what this project is and what it's supposed to do. So there's a bunch of little sort of library things I wrote here for it. This was originally an undergraduate project I did in some AI machine learning stuff. The idea is that we have a bunch of things here. So this is a list of all of the objects that are allowed to exist in the world. I think this is... Yeah, so this is the complete list. They have an ID so that you can refer to them easily, and everything has a shape, a colour, a size. This last column is whether or not the object casts a shadow, and this number on the end is the impact it has on your energy when you find it the first time. And you will notice that there are 3 that have an NA for energy. These don't exist in the training world, only in the real world. So the aim here is that everything else, so there's, 33, I guess, objects exist in the training world. If you manage to find all of them, then you should be able to correctly classify the effect that these will have on your energy levels when you find them. We have a training environment, which is just a list of which ID you find in which cell. So typically you start in the bottom left, you have some energy, you run around for a bit. If you make it back to the bottom left without running out of energy, you get to learn everything. The test environment... Whoops. Let's try not dropping phones on the floor. Yes, I use VSVim. Don't at me. The test environment is the same principle, but there are some things in here that have NAs. So we're looking for 11, 21, and 24. So we've got an 11, and 21, and a 24. And the idea here is that, in fact, we try to get from the bottom left to the top right with different amounts of starting energy. So, this is all very boring and wordy. So in theory, what I should be able to do here, if I do a start without debugging and switch the scene. So this is the agent represented by the little @ symbol, running around the environment, learning about things. Oh, it technically isn't allowed to have learned any of that, so that is definitely a bug in the code. Let's add this to the list of to-do things. And this is why there's also a need to do some testing on this. But the principle is still shown by this, so you can see it's going to run around the environment a little bit. It's going to try and learn some things. What I will actually do for a second, just to make this a bit faster, if I can remember how to do this. Oh, yeah, you do it on the project. I'm actually just going to disable the rendering part just to give this a quick run through so we can see what happens afterwards, because it's a lot faster. So, the bit that's hidden behind me, it basically just lists 32 to 36 as extra IDs it's learned. Then you can see here it's printed out a decision tree. So from the things it's learned, it knows that if you have a circle, it does nothing. Doesn't actually matter. Or what its belief is that if you have a circle of any type, it does not change your energy at all. If you have a diamond, and it's a small diamond, it doesn't change your energy. If it's a large diamond with no shadow, it doesn't change your energy. But if it's a large diamond with a shadow, it does -5. And squares, it's just whether it's a large or a small square. Large squares give you energy, small squares take energy away. If we go and have a look at table 1, so what did it think here? Circles. Let's have a look for circles first. Circles, yeah, looks like circles do nothing to your energy. So it's probably got that bit right. Squares, small and large squares. So all the small squares look like they do -1, except for this one. So it's probably going to classify that right. I would assume this does a -1. And large squares give you 2. Yeah, that also looks correct, and again, should then classify this correctly. And then you can see how this works for diamonds. You've got large diamonds with a shadow, large diamond with a shadow. This would also be a large diamond with a shadow that's going to do -5. And all of the rest do nothing. So, it does this, and then these files it outputs here are how it gets, or ways it can get from the bottom left to the top right if it starts with 6, 7, or 12 energy. We can also work this out statically, but we can probably just take its word for it at this point. So, this bug, probably something fairly important to fix to start with. So, let's go and have a look at it. So this is probably going to be in the agent code. I also could not spell 7 years ago. There should be... Okay, that... Don't know why I made that a separate function. Unless it's called by something else. Okay. Yeah, so also here there's some horrible stuff. So the agent kind of exists in the world, but the world, like, keeps track of what the agent knows. It's a bit sketchy. So that's something else that we're going to need to fix. So this bit actually seems to be reasonably well commented. So when it starts running, it looks in the config file for how many runs it's going to do. So by default it's set to 100, which is a good number for learning as much as it possibly can. We want it to be in world. And then for however many runs you've got, it will make an agent, which was this function here that just dumps the entire history in. What we should actually probably do instead of this is get an agent to return its next generation to the world, rather than the world actively creating it. There's some stuff for rendering. Then we take a step. I've not tried Visual Studio for Python. Does this... Oh, it does actually work. How good is that? Props to the Visual Studio team for making this work so nicely. Also, for anyone who's curious, this is the new Visual Studio 2019, which has some nice funky features and still supports VS Vim. Or VS Vim still supports it, either way. So, what we do here is... What do we do here? Oh, okay. This is, we build up a vector that lists, or a list that says which directions it's possible to move in. And then the agent makes a decision. And then it moves according to its decision. I didn't want peak, actually. I wanted to just go there. Probably help if I switched the scene back. That would be useful. You can tell I'm not used to this whole live coding thing yet. There's a list of static agents. There should be something that calls alive. Okay, so while it's alive and it's not at the goal, it does some stuff. So actually the first step should be quite easy. Is if self.agent.alive actually that's exactly the same as alive. So I'm not entirely sure what I was doing there. So what we do here is we store a list of actions. And we store a list of locations. So I will come to explain the way it makes decisions in a little bit. Let's also just configure this to use a little bit fewer in the number of runs. Because in theory, okay, so the problem is actually not whether or not it learns it. The problem is actually in the rendering. So what adds to self.ids? Oh, no, okay. Self.ids is the map. Okay. So what does draw do? Takes a renderer, which run it is, the agent, a list of IDs. Okay, so that's just printing out an agent string. That should also actually probably be part of the agent code, I would think. Maybe, maybe not. It might make sense to have the renderer poke in and work everything out. So this should just copy whatever the agent has actually learned. Which means that if it dies and we're rendering, we need to clear the list. So it takes a step, and then if we're rendering, draws everything for that step. This should actually, we always do this bit after a step. So actually that should probably just be part of step. And that would make this code a little bit neater. Okay. So if this renderer is going to let's set the energy to like 4. That makes it quite likely to die. But we could set it to 1. That would actually make it very likely to die. I think as it currently exists, it will just immediately die. But let's just give this a quick try. Oh yeah, I need to actually make it draw again. Hey! I is not defined. Where did that error happen? World.py line 46 in step. Ah, that's why it's not done there. Fine. We'll put it back there for now then. Okay, that's basically behaving the way we expect it to. So what we need to do, like I say, is clear the self.learned. So this copies the agent.learned and writes it, which is suspicious because that actually then suggests that the agent.learned is being sneaky. Beginning to wonder if actually it's going to be easier to okay, so if we actually make sure that the agent nukes its own memory as well, then we're not learning anything, which is a good start. Let's give it some more energy and see what happens next. That behaves exactly the way we want it to, in fact. This is indeed good news. Okay. Yes. So the reason behind this is I tried using a library for the project originally. And the library I used, I forget which one it was. This was back in 2011, 2012. completely failed to do decision tree learning on the data set we have. So I went and looked up the ID3 algorithm, which apparently is a really old hat. Certainly now it is. And what I actually then did was, in the space of 109 lines, for at least the format of my data, build the ID3 algorithm. Yeah, in general, I prefer libraries. In my defense at this point, it was like a 1 week open assessment, and I'd spent 2 days, I think, trying to get this library to classify the data correctly. And I couldn't, and it's like, okay, I actually need to finish writing this code and write a report, so I'm just going to write it, and I'll work it out later. Okay, I'm going to set the energy back. And I have at least finally fixed the bug that has existed. Oh yeah, it's ridiculous. But also now, as long as you can actually formulate your data in the way I expect, I can give you a really small Python library for doing ID3. So if we go back to this decision tree file, yeah, so it, in the to-do list, in fact, is commenting and documenting this file, because I only know it's ID3 because I happened to write it in the report. So if you've not seen ID3, the premise is you have a whole bunch of attributes, and it does a greedy heuristic to say, okay, which attribute gains me the most information? I'll classify everything on that. Okay, that strips out all this stuff. With the data that's left, what gives me the best information gain? And just works its way through that way. So we have a function here to say, where is the lowest entropy? This is just a thing to print it out. Calculate probabilities of leaf values. I have no idea what this function means. Oh, no, okay. This is the probability of... oh, yeah, which way the probability works for how it... in fact, we can have a look at the thing now it's finished. So it's these probabilities is what that's calculating. Like how likely it is to have a certain impact. In our crappy data set here, it's pretty obvious if you actually get it right. Oh, wow, it does really badly in 10 runs. Still classified everything correctly, but... yeah, so this just builds up the output dictionary with labels that are kind of hard-coded for the use case we have here. And then some generic functions that are based on, in all honesty, probably the Wikipedia page for ID3, that just calculate gain and entropy for... Also, this is information gain, specifically. For a specific attribute at a given point. So for each record in the data, if your record has the attribute, then you add one to it. Oh, yeah, this is the whole, like... Yeah, hang on. Let's find Wikipedia again, because I knew this would be useful. So, this page should do it. So what it's trying to implement approximately is this. And this. Wow, Wikipedia does not like having my chat window over the top of it. But yeah, so that's the general principle anyway of what this code was trying to do. I might at some point try rewriting this in C++, but to be brutally honest, I kind of despair of ever trying to write a curses-based interface in C++. That sounds painful, to be perfectly honest. Okay, so it missed a whole bunch of things. So if we don't render again. So yeah, it still misses 14. So 14 is actually the hardest object for it to find. But I think we can fix that with a better exploration algorithm. First of all, that to-do item is done. It's a whole bunch of like really tedious stuff to do here. So let's have a look at the world. So the world gets given a map and a bunch of statics. What statics does it get given? I'm assuming then the statics are... What are the statics? Hang on. So it's config map statics when you make a world. Config map. Okay, the statics is just the big table. Fine. Set a whole bunch of stuff up. Yeah, okay, so it loads the start, it loads the goal, it loads the energy. So I'm assuming that link then, yeah. Okay, so it actually passes it into the planner, which is a very different thing again. Where does the planner live? Oh, this might have been where I started trying to write effectively like Prolog, but in Python. So it does this ridiculous depth first thing and then uses a verifier to apply the Prolog style cut operator. So anytime a path it wants to use fails. Yeah, so it tries to basically use a Manhattan distance because things aren't allowed to move diagonally. Stop if we have no energy. Yeah, so it just works through and works out boring stuff. So this is the recursive planning part. So it just says at any point, if it can go in a direction, try it and see what happens. And eventually it comes back and it tries the next one and does it that way and just builds up a whole list of paths. Yeah, so it will return nothing or a trace. And then it just returns, everything that it knows that finds a route. Okay, that makes at least some degree of sense, which is more than I can say for some of it. Okay. So the idea of the action history is that for any given cell, we keep a record of which actions we've taken from that cell before. Which is really more of an agent thing than a world thing. We also keep track of which locations we've been to. So an agent will make a decision based on two things, really. In principle, one thing is that the idea is it strives for novelty. So if it's in a cell and it's already taken every possible route from that cell, it doesn't care. It will just pick one at random. Otherwise, it will pick one at random from all the routes it hasn't tried. And then it just tries to build up that list and say, hey, I've, not been a certain way before, let's try that way. But there's better ways that we could do that, I think. What does self.speed get used for? Because I have a horrible feeling that speed is actually... Yeah, how long it sleeps for. Yeah, sub-second precision. Okay. Oops. So in theory, we can actually make it go a lot faster by making it... Well, that was quick. That's because it's not actually rendering. I'll say I thought that was a bit fast. Oops. Okay, this is a much more sensible speed to watch it render at. The only thing I have found is that with the Windows version of the Curses library, it doesn't work out scrolling or anything, so you do need to make sure that you have your command window start large enough to hold everything. Because this is just going to print out a whole bunch of errors. and I can't now see what things it's learned, if anything. There's a slim chance it will actually learn about agent or object 14 up in the top corner there. But we'll see. So, let's go back to having a look at this world and working out what things it makes sense to keep here and what should actually be factored out into the agent. So really, that should be given to the agent. That should be given to the agent. Well, that's actually already in the agent as well. This is actually more of a duplicate. So all the statics, if the ID in the list of... Okay, so when you first make the world, you know about the thing in the bottom left corner. Or the thing in the start cell, more accurately. That should also be in the agent. Has it learned about 14 yet? Oh, it did actually learn 14. That's pretty good going. So yeah, it's, you know, done a whole bunch of classification and stuff. Okay. So let's start refactoring things. What I might actually do at some point tonight as well is I saw a fantastic talk a little while ago. Let's find a link for the chat, because anybody who's actually interested in this sort of stuff should probably be aware of it. So if you want to test legacy code that does not have adequate testing yet, there is a talk here that is well worth looking at. And this is something I'm going to be looking at adding to this at some point. I want to make sure I get the library set up offline first, because no one needs to watch me failing to set up libraries. So for now, we want to first of all finish. So we're going to change the way that works. So we actually want the agent to return the next agent. I'm actually going to rename this to make it a bit more clear what it actually is. So every agent ever will be allowed to start with knowing what's in the start square, which is kind of a side effect of the way the agent works. So what we want to do here is this, and then everywhere where we have a self.agent in the rest of this method, change it to just agent. In fact, what's the next generation of an agent? So once it's moved, if it's dead, it nukes anything it's learned. It's not allowed to learn it anymore. Behaviours as described in the documentation. Persephone was, I think, possibly over brief in terms of in-code documentation. That's definitely something that needs to... Oh yeah, the escape method. Which is... So, the way this will work is, I think it triggers from explore, if I remember correctly. No, is it not explore? Okay. It triggers from somewhere. Oh, here we go, yeah. So, decide, which is the function that it calls to work out which way it wants to move. Which literally just says, if I have at least half of my starting energy, I'm going to try and explore. Otherwise, I'm going to assume things are going badly and try to escape. So the idea of this is it's trying to maximize its chances of learning things. This could also be improved, but it's going to make the code a lot more complicated, so we're going to need to think about that in a lot more detail. So, for now, okay, for now I'm going to leave the goal check in the world. That ultimately is going to need to be dealt with by the agent as well. So this is going to keep going as long as the agent is alive. And what we will actually do here is just make sure we sort the agents list, because that will get a bit weird otherwise. While it's alive, do some stuff, sort it, and then agent.lock wants to be, presumably, self.start is fine. Yeah. So, what we do is we just run until the end, and then when the agent is done, we reset it to the start position. We also don't want to recreate the agent every run. We want to create the agent once. And then this is effectively creating the next generation. Given that the agent can already handle what it knows, so if it dies, it forgets everything, which is all that's really required to be able to pass things on to the next generation. So, in theory, at this point, we should be able to rerun everything. Ah. In step. Okay, yeah, so we need to... So what happens is the agent needs to make a decision and then query the world to say what's at this location. Do we pass the world into the agent? So, when we make an agent, we now pass the world into it. And then this function becomes a function on the agent. But this actually wants to be a public function on the agent. So this can still do with some more tidying up later, but at least this function is now in the right place. Global name world is not defined. Yeah, because that's supposed to say self. Well, definitely broken something there. That agent's desperately trying to escape with lots of negative energy. And of course, that's because we also need to reset the energy. That's more like it. So now it's actually exploring again. And interestingly, keeping a record of... That's an unintended side effect, but not one that's totally out of it. So this is a more visual representation of where it's been. I'm not sure if it's better or worse, in all honesty. Yeah, so it's still not quite making it up into that top corner most of the time. But that's the only cell it's not been to, and it's got 60-odd runs left. But this looks like it's actually a promising improvement so far. So what then? It's because of the location history. So previously, we would have been copying the location history, or we were blanking the location history. believe is what was happening. No? Okay, we weren't blanking the location. We were blanking the traces. That's what's going on there. So for the time being, just to make sure the behavior stays the same, list indices must be integers, not tuple. Okay, so line 92 in explore. Oh, okay. That's because I messed up. These are not supposed to be lists of things. Okay. So now this is less broken again. We do have the slight oddity that it's now never drawing the initial square. Let's have another look at that make agent. Oh, it's also no longer properly learning things. So in fact, what we actually also need to do what was the new thing we added? Agent.static. So, what we now need to do is work out why it's no longer keeping the initial thing, or the start state in the location history. And I'm assuming it's because we actually need to kind of cheat it a little bit and tell it that it's been in the start. Yeah. So now we can see it actually starting to learn again, which is, you know, what it is supposed to do. So, bonus! That one died, that one also died, that one also died. So now it seems to have got stuck in a loop where it can only go one way. Which is awkward, because that way is not going to let it learn anything. Fun side effect, though. We can probably stop watching that. Where's the to-do list? All of this is also going to help when we actually start coming to test this properly. Is there a... There is a Python unit test. Because we can actually test the decision tree fairly easily, I think. Because... so unit test.main... So what we should be able to do is... We definitely don't want to be overwriting that file. Actually, should we do this in a more Python-y way rather than a silly way? Okay. So that gives us our list of objects. And we want to import dtree. Want to create a tree node. How do we actually create a tree node? Where's link gone? Did I close link? That seems like a silly file to close. Okay, so I want to also parse it slightly to fit that form. Color size shadow. Okay. So the idea here is that, at least with a very basic test, because we can statically look at this input file and tell what the answers are, we can actually test it. And then do we actually have to do something? Okay, no, that should actually... if I do it right. So what we do is, if we get objects to be parsed correctly, then NA becomes none. So this will find us all the known. If not, I reward. So we actually then want to pass in known into this. Basically, I just want this to be what the statics reader does. Okay. Okay, so we don't actually care about the ID. So 02134, apparently. In shape, color, size, shadow. Is that actually the shape, color, size, shadow? Should be 0123, surely. Okay, how can we dictionary comprehension this? If we know what all the key names are, if anyone in the chat knows how to dictionary comprehension, where you know what the keys are ahead of time. That's all good. I have to admit, I'm kind of borderline hoping Fran stops in. She could probably answer any of these questions just off the top of her head. Actually, that's a point. When I'm doing live coding things, I should probably at least have like a little #include badge or something on my stream. I know I'm doing Python, not C++ at the moment, but still, you know. I want like a dict zip thing, basically. So out keys I equals V, I think. So if it's reward, reward might be NA. So in theory, that should sneakily fix everything for us. And since things should come out in the order they go in, we should get 0, I guess. Oh no, hang on. It's a large diamond with a shadow. So it should be -5. Maybe? Hang on. Diamond pink large, yes. Diamond blue large, yes. Diamond yellow large, yes. So large diamonds with a shadow should be -5. Looks of it. Oh yeah, we don't have to classify circles, that's the problem. So it should be -5, -1, 2. And refresh myself on how to actually call this again. Classify UDAT. So what does this actually return? Branches.classify. Thanks. Oh, okay, no, it's just this. So it returns a list of probabilities. Unless there's only one, in which case it returns... Is it reward? Probs. So what is probs? It's a dictionary. And what do we put in the dictionary? Something. Okay, this might be a job for opening up a command prompt. Should be in the right place. So from lib dot learning import dtree. From lib dot learning import id3 test. One of the key advantages I always do find to using Python is it's like if you need to work something out, you can just kind of quickly bash it together in an interpreter and see what happens. Assuming you can spell. Spelling is an important part of programming. Okay, so we have a bunch of things, except the NAs have not become none. But we should be able to fix this fairly easily. I can't see any NAs in there, which is a good start. There we go, okay, so now they've correctly become nuns. The known should be a bigger list, and unknown should be a short list. This is indeed a good start. So we want to pass in all the things that we know about. We want to pass in the list of keys. And we want to pass in the attribute we're trying to classify for. Unhashable type list. Okay. Is that not how this works? It's a list of dicts. Is that not what this is? This is also a list of dicts. Line 87. See, this is what testing finds. Oh, absolutely. Like, there's advantages both ways around, but freak.hasKey. Oh. I think I know what I did wrong, actually. Yeah. It's a really obvious mistake, is we're only looking for one target attribute. Hooray! That looks like a big memory address. Okay, so what is unknown 0? It's a large diamond. Res tells me -5. That has a string, which is an interesting thing that I wasn't expecting. But that's fine. trying to return 2 replies is an interesting thing from a web server. Yeah, my biggest bugbear with dynamically typed languages, of which obviously Python is one, and where I've had most of my problems, is that I have managed to give meaningful but identical names to completely different things, and then wonder why it was like trying to call an int or increment a function. I was like, oh, because that member and that method have the same name. Well, member data and member method have the same name. Oh yeah, it should actually probably be just a comma. Okay. Oh. Yeah. Hooray, that's a good start. Dot slash. Dot slash. Unless it's actually trying to run from the project root, which would be almost disgustingly useful. Ah, and that's because I didn't fix this. See, tests. Tests actually help you fix things, even if at the moment it's just telling me how to fix tests. There we go. We've tested the classifier. It classifies everything the way we expect, assuming that you do manage to learn everything. Okay. So then, we can obviously extend this to try and trip it up and see what happens if it can't quite tell what it's likely to be. I don't know, actually, if we can do that with our current data set. We could certainly forge a data set. So it's just a text file. But this will also be a good test of the classifier in general, because we should be able to completely change how this works. Okay, so in theory, this one, it shouldn't be able to work out Well, actually, it should eventually be able to work out something from it. If we then added in a C as well, then what we should be able to do is set some of these to be NA in some way. So actually, if we just set the C's to be NA, so it doesn't know anything about C, but it knows about 1 and 2. This could actually completely break it. And now I'm actually genuinely curious. This is just so I can sneakily generalize my test writing. Line and also keys. And also keys. That's because I'm missing an underscore. Yeah. Literally just got there as the message came in. I'm not even going to bother changing my expected results because I have a horrible feeling that this is actually going to completely explode. And take that out. My reward. Reward is a known key. Why do you not think it's a known key? Where did we build this one? Because it's called test class items. Uh-huh. Okay. Letter. Okay. So what have I done differently in this to in table 1? Oh. Yeah, okay. Oops. Yeah, that would do it. Do all of these have like an extra character on the end? Or something bizarre? Okay, I might need to make the parsing slightly better. Honestly, that should probably fix it if it's what I think it is. No, that's where you need the R strip. Okay, that fixes it. Seemingly. Oh! I'm genuinely surprised my code actually did what I expected it to do, which was say, look, it could go either way. In which case... what did it actually output there? Okay, so it's a dictionary of result to probability. Which, for one thing, also tells us what the return of this is. Okay, so at least now we know how that function is expected to return. So we expect it to be either 0 with 0.5, 1 with 0.5. In fact, we expect that for both results, with the ridiculous data we put in. Oh, except it returns everything as strings. So let's just stringify everything. I disagree. Okay. So we've proved that actually, not only does it handle the trivial data that we started with, but it will even handle being asked to classify something it doesn't understand if it's got enough data to make a guess at it. Although part of me now does want to see if I can really throw it off. Because if we, just as an experiment, try that. Really? Huh. Problem is, I also don't quite understand how ID3 is supposed to work well enough to know if that's what we expect. But it doesn't seem unreasonable. If it knows that all of the values here are 0 or 1, then it can probably hazard a guess that it's going to be one of them. Anyway. This has been an unusually long stream for my first one of these. So I am actually going to call it there for now. I welcome feedback from anyone on if this is the kind of thing that's interesting every once in a while, how it went, ways to make it better, stuff like that. Yeah, let me know here, Twitter, wherever. And until tomorrow, I will say goodbye and thank you for joining me. Bye.